Hello, my name is Sonola, and today I will be presenting my team's project, Traffic Queue, pretty much a system to visualize and forecast traffic trends in Atlanta. First off, our motivation came from the limitations of our current traffic dashboards. They're mostly static and don't allow users to explore station-level trends or compare forecasting models in one place. Accurate annual average daily traffic, or AADT, from here on out is essentially for planning, budget, congestion management, and safety decisions. We've ultimately wanted a system that unifies visualization, analysis, and forecasting in a single browser workflow. Our approaches bring together a leaflet map and D3 time series charts. Users can click any station, explore decades of AADT history, and directly compare model predictions. We also applied PCA and K-means to understand the structural patterns across the network. For forecasting, we implemented linear regression, random forest, ARIMA, and LSTM to evaluate how different model types behave on the same dataset. Our data included multi-decade AADT counts from the Georgia Department of Transportation, merged with station shape files. We used all years up to 2023 as model features and used 2024 as ground truth. After cleaning, we had tens of thousands of rows representing stations across the Atlanta area. We used an 80-15-5 in the sense of 80 train, 15 tests, or 80 train, 15 validation, and 5 tests. For experiment focus on approach, PCA showed that the first component captured about 99% of total variance. This makes a lot of sense because the AADT trends are driven by broad regional forces like population growth and roadway expansions. K-means naturally separated the stations into two clusters: high-volume interstate corridors, which are highways, and lower-volume local roads. For results like LSTM performed poorly. Our results like LSTM performed poorly with the R-squared below 0 because annual data was too sparse for deep sequence models. And linear regression reached R-squared of 0.991 with an RMSC around 3,129. Random forest improves with R-squared around 0.998, RMSC around near 1,600. Riemann performed the best with R-squared near 0.998, or almost 1, and RMSC around 1,522. These outcomes make sense ultimately because random forest and Riemann capture the non-linear of gradual year-to-year patterns that appear in the AADT, while simpler models in deep learning struggle with short annual sequences. Thank you for listening to my presentation.